So yesterday you focused on the difference between different what we call tonicities. So hypertonic, hypotonic, and isotonic solutions. It's a good example of some of the specialized language that we use in science that, to be quite honest, can be a little bit of a problem for students as they learn it. It just seems like there's so many terms that are very specialized and aren't that familiar, and it seems like the game is just to memorize everything. But the beauty of what you're doing right now is that there's no expectation that you memorize anything. You are welcome to use whatever notes that you have or look something up. But the main goal and what really makes science, I think, important is the ability to apply that knowledge. So I'm not all about memorization. So if you want to look up what those terms are and just be able to apply it, so when you look at a solution, you can recognize which type it is. That's really what science teachers are after as you learn this, because that's a much more valuable skill than memorizing. In today's lesson, you're going to see three other terms, and these might be more familiar to you, I think, than yesterday's. They are saturated, unsaturated, and supersaturated. Okay, so I'm going to give, again, as usual, a brief description of what those are in the next video, and then a chance to apply them, not to see if you memorize them or not, but to apply them. So a little bit of graph reading in this, which again, as a science teacher, I just think is a super important lifelong skill that you're going to need. It's going to be valued when you go out there and work in whatever job you may work in someday. Probably your ability to make sense of some graphical information is going to be very highly valued. So use this chance to practice it without the pressure of having to sweat and memorize stuff. I think it's a good time to practice that kind of thing. So the buzzer went off. I guess that means it's time to end this. So I'll let you get started. Have yourselves a good day.